Hi, good afternoon everybody. Thank you for joining us on New Tech TV. My name's Liam Hayter and I'm joined today by Dean Offord from Panasonic. Thanks for joining us today, Dean.
Hi Liam, thank you very much for having me. How are you doing?
Very good, thank you, man. Very good. So you're joining us from over in Bracknell, I believe, via Skype.
Yeah, very sunny Bracknell, 4 seasons in the day, UK. So yeah, and you're in London, I believe.
Yeah, I'm indeed, yeah. So I'm sort of operating and presenting today on our TriCaster down here. But just quickly, Dean, I just thought I'd hand over to you if you'd just like to introduce yourself to everybody.
Yeah, absolutely. So my name's Dean Offord. I'm the sales engineer at Broadcast Pro AV inside Panasonic, and I'm mainly responsible for PTZ cameras, but also softwares. So it's a huge amount of stuff that we do as Panasonic, and I've been here for about 6 years now. And actually, I joined at the start of when we started implementing NDI HX. So it's been a really great journey, and actually I'm quite excited as a personal fan of NDI to discuss this, and also having worked with Liam over the years for many projects and events as well.
Fantastic, thank you very much, Dean. And just to introduce myself, everybody, my name's Liam Hayter. I'm the Senior Solutions Architect for New Tech in EMEA. So I get involved in systems design, working on joint projects like the likes of those that me and Dean have been working on, get involved in our training and pre-sale support. My background, I've worked in post-production, live event AV, all sorts of different angles of digital video over the last 20 years, and NDI is just one of those technologies that kind of really brings all those different aspects together for me. A bit like Dean from the music background, I'm actually from a fine art and photography background originally, so we've kind of both coming from quite a creative angle for these types of applications here as well.
Yeah, and I think that the main thing we're talking about myth busting NDI as a session name, but I think it's if you're new or you're existing user of NDI, it's best to get an overview. And I think the main question, Liam, is what is NDI? Is the first question.
Yeah, 100%, and I'm more than happy to help unpack that. So if we look at what actually NDI stands for, a lot of people misconceive that it's New Tech Device Interface. It's a network device interface because basically it does exactly what it says on the tin and allowing us to use video and audio over networks. NDI is a compressed video and audio over IP protocol developed by New Tech. We announced that in 2015, and Panasonic were one of the earliest partners that joined on with us with NDI. And it allows you to carry both video and audio over your existing networks. And to do that, we ensured that NDI was designed for gigabit Ethernet networks and beyond, which means even though it will work on a standard gigabit network, if you have a 10 gig, 40 gig, 100 gig or even higher in the future network, all that will do is actually just scale up the amount of capacity and the amount of streams that you can utilize on that video network. But as you'll see, NDI also supports lower bandwidth networks too, with things like NDI HX, which open up a whole raft of different potential workflows that are out there. NDI carries video and audio and metadata as well as control. So it's not just video and audio that's involved, and as we get more into the camera side of things, you'll see where the control part can really kick into its own. And we use modern efficient encoding within NDI so that we can deliver ultra low latency but also keep the resolution and the frame rate and everything else true to the source. In our own internal tests, we've encoded and decoded NDI thousands of times before we see any degradation in the actual image quality that's coming through. And with that, we can support any frame rate, any resolution, these include non-broadcast resolutions, and any color space. We announced last year that NDI will actually now support up to 16-bit color, which opens up the pathway in the future for us to potentially look at supporting things such as HDR somewhere down the line. But the actual technology of NDI can already support that today and is adjustable enough to actually be able to accommodate already things like 8K or 16K in the near future without a major overhaul necessary on the devices that are being used as well. With that, NDI is software defined, and so that's where we can ensure that we've always got forward and backward compatibility, and we can actually update the software and the NDI libraries on devices rather than necessarily having to update the devices themselves as things evolve and as NDI matures and evolves even further than it has done today so far. And to make it nice and easy to use, NDI has got automatic network discovery, which is based on human naming conventions. So when we name devices, that's what we use to actually operate and connect to sources, as you'll see shortly. And another big benefit to NDI is this isn't just a linear protocol like some IP protocols. It is fully bidirectional. So any device that can send NDI can also potentially receive NDI. In some cases, we can do this simultaneously over the same connectivity. And if you partner that up with the actual compression technology that we use within NDI, we can actually effectively replace the job of up to, say, 14 SDI 3G tie lines within NDI by actually using a gigabit cable, because we could send 7 streams in and 7 streams out of HD, or we could do 2 4K and 2 4K out to reduce the cable count from 4 12G lines down to 1 single gigabit Ethernet cable as well. So, Dean, you've had some experience with this as well, haven't you, on the control side of things with NDI?
Yeah, absolutely. And as you said earlier, Panasonic became an early adopter of NDI-HX workflows. And the main reason for us is that we started introducing in our PTZ power over Ethernet technology. And this is using PoE Plus as a standard. And the fact that we could take the video, the control, and the power and plug it into the PTZ, this Cat5 cable can run up to 100 meters, which is absolutely phenomenal to get all that kind of power and data in one go. So for PTZ installations or even flyaway applications, you can actually really start to see the benefit of this. And I can even safely say, as trade shows, you know, we use this, and an example with the PTZ, having that constant back and forth of the bidirectional data going to your NDI production, whether it's using something like a TriCaster system or HRC 100 system from us, and then being able to relay that to the cameras, and also the tally functionality, being able to switch it over IP without complicated GPIOs in the back, is absolutely phenomenal. It's so simple.
Yeah, and indeed, for anybody that maybe wants to actually start testing out with NDI on their own existing network and seeing just how straightforward and simple this is to use, we give a range of free NDI tools which are available from www.ndi.tv/tools for both PC and Mac. And again, you guys have been using these tools of ours quite extensively as well, haven't you, Dean?
Yeah, people love free stuff, and we're no different. So Panasonic, we use these tools regularly. Things like Studio Monitor is great. It's just a PC software that I can run right now, and I've been using it for filming the PTZ NDI streams inside my apartment whilst I'm away. Scan Convert is great because I can just turn my laptop into another NDI source that can be activated and switched using, again, say like TriCaster HC 100 system, and also virtual input, because now more than ever with the current situation, while we're even doing this, being able to convert NDI cameras into USB sources is really important, isn't it?
Yeah, it's a really, really powerful little tool, and particularly when you start wanting to work within, say, remote production, start integrating with teleconference, things like that Scan Converter tool allow you to use NDI as a source into any of your favourite video applications that will support, as you say, things like a USB-style webcam or microphone in there. And in fact, we've just announced as of last week now that we now support Scan Converter on Mac as well. So all those workflows that we've been able to do for PC for a long time, and to a degree with Mac, are now completely in tandem and in line with one another as well.
Yeah, and I think the biggest question we get, Liam, is immediately out the gate, or any kind of project, what is the difference between NDI and NDI-HX? Because they hear these two words over and over again.
Yeah, and it does come up a lot, I think, for all of us as well. I think at its core, really, I think it's key to point out that actually they're still NDI. They're just different varieties of NDI. And in fact, we've actually got 3 different types of deployment out there that we can work with. We have high bandwidth NDI, as we call it, and then low bandwidth NDI-HX, which stands for high efficiency. The idea behind this really is that NDI started off in the computing world. As I said, we're a software-defined technology, which we first brought out onto our VMC system when we launched that back in 2016. And actually, NDI is part of all of our TriCaster systems, so they'll actually be able to consume and send out NDI on that network based on computing hardware, and that's the same with your HLC 100 systems. We're all running on a Windows backbone to deliver that. When we had a really great such the great reception to NDI, that we started immediately getting demand for people to implement NDI into cameras. We've long had the ability to actually use our RS422 over IP, and we controlled that from within our TriCaster systems. So it's a logical step that customers would want to start seeing camera product out there. As you said earlier, Panasonic were one of the first on board with us on the PTZ side of things, because we developed NDI-HX, which is, as I said, it's a more efficient version of NDI, but it's designed to utilize existing encoders that are already in products on the market. So that could actually open up a whole range of different cameras and converters very, very quickly, but also utilize lower bandwidth because the actual processing power on those encoders isn't quite the same power as, say, an Intel processor. On that note as well, though, we then actually have a different side of NDI, which is on FPGA implementation, which is where we can now start putting NDI into actually dedicated video hardware. So we start seeing things like mini converters and so on, which will be out there on the marketplace as well. If we actually look at the actual specific different types of NDI that are actually there and look between the actual technical side of it, there is actually two different data rates that are being used. There's 150 megabit per second for full bandwidth NDI, which is at 1080p 50, and we're also looking at 14 megabit per second for 1080p 50 when we're looking at NDI HX. When it comes to 4K, the data rates are different again. We're looking around 375 megabit per second for full NDI, and then we're looking at 27 megabit to do the new 4K implementation of NDI HX as well. The only other differences really between the two technologies are actually that there's some different transports being involved. With NDI, you're looking at UDP with forward error correction, which means that we can actually send packets of data to actually correct in the event of packet loss on the network. Whereas with NDI HX, most devices will tend to use UDP, which is more of a send and forget type of methodology for transmitting on the network. But again, it has some real strong benefits within more efficient workflows there as well. So, Dean, do you want to talk a little bit about the latency side of things that you were seeing on this as well?
Yeah, because latency obviously exists in any form of whether it's digital or analog anyway, and NDI has 3 frames of latency and NDI HX has 5 frames of latency. I get in trouble because I do a low fat milk and full fat milk analogy, so I'm glad that you've explained that properly instead of me. So yes, the great thing about NDI HX and 5 frames, people get put off by this figure, but there are many productions that are being done using PTZs running NDI HX, for example. Even alongside the different NDI workflows, we do have different tools that we're going to talk about where we're considering things like the audio and every other part of the technology in the workflow for the ecosystem. So it is totally manageable because we have these software assistant tools, don't we, to be able to manage it.
Yeah, we do indeed. And I think if we actually start looking at some of the ecosystems as well that we can build around that, you guys have been doing quite a lot of work around sort of flyaway kits using both types of NDI, I believe.
Yeah, absolutely, and it's more important than ever, having really simple workflows that you can quickly deploy. And Liam, you and me have done events at things like Red Shark in the past where we actually did the whole event using NDI HX, and this was exactly kind of the similar setup that we used. And you could just see it's Cat5 E is a minimum. You can go up to Cat 6 if you want to, connect it to a switcher, and then in this case, I've got the HRC taking in the IP feeds, and then we can feed it out. So it's great because it's a super simple way, and we're not showing anything extra here, and that's the kind of core point for Flyaway, quick deployment, and that means that we have small flight cases, and that means you can do more gigs because you can pack it away simply, set it up simply, and then go. And as you said earlier with the human messaging inside the camera, so we know which ones are going to be where they are. Every time we set up again, it's the same session, so it's a lot easier to do over and over again.
Yeah, we can completely base it on that standard human naming conventions that go out there, and I think this is part of the great thing with NDI is that we can actually start on very small systems, and then we can scale all the way out. So you could actually quite easily have a flyaway kit as part of a larger ecosystem or larger infrastructure, which is the type of products that we utilize within NDI, and then you can scale all the way out. And if you want to take elements of that away with you, it's very easy to detach them because they're just using standard RJ45 just to be able to unplug and then reconnect elsewhere on the network when you get back to base. And I think it kind of then goes without saying that actually lower bandwidth on your network is no bad thing. It's actually really beneficial in a lot of instances, especially on that flyaway side, like you mentioned, Dean.
Yeah, totally. Even I think everyone watching this can relate at home, when parents are screaming at their kids to get off of the internet or something, or vice versa. Even though I'm aware my bandwidth might not be the greatest at home, that's because, in my flatmate doing a call right now, it affects, and if you want to put more devices taking up more bandwidth, this is even applicable, especially in productions and things. So we can say it's a good thing, and we're about to explain why as well.
Yeah, and I think without further ado, I think that kind of takes us on to one of the reasons we're here, which is to start actually looking at some of those NDI myths that you and I both encountered out on the circuit, and start addressing some of those directly for our audience today.
Yes, absolutely. So the first one that normally comes up immediately is I'm a big analog fan of my current workflows, and video and audio over IP is just too complicated.
Yeah, exactly, and that does come up a lot. And I think it's quite good to sort of explain actually how all those sort of elements within NDI come together as a user from a user perspective, particularly actually start addressing about how this operates on the network. So we're going to try and keep this quite straightforward. Again, we're not going to go into too much detail on it, but the way I tend to sort of represent it when I'm planning out an NDI solution is to basically just draw a large circle and start planning from there, because really the main thing we need to start watching out for is things like stream counts and device load. But in principle, it doesn't really matter whether this was a large network. It could be the size of a stadium, it could be a broadcast studio, or even a flyaway. The actual modes of operation on a signal subnet are going to work exactly the same way. So on one end of the network, I can put an NDI device. This could be a camera, it could be an I/O device like our NC1 I/O that's pictured here, that allows us to bring in 8 streams of HD SDI directly into the network. And then at the other end of the network, we'd put a production system. This could be a TriCaster or an HLC 100. This could also be a mini converter or just a decoder, because perhaps we want to use NDI purely as a means of getting video and audio from point A to point B. And as we go along, you can populate this network with as many sources as you want. Every source would be given a name. So we'd have camera 1 studio A or production system 2 or whatever makes sense from an operational standpoint on your network. And at that point, those devices don't really start transmitting any audio and video data to a high degree. But what they do is out on the network is they do an MGNS broadcast. And every device every second pings out its name, what its IP address is, what it's capable of, can it be controlled. And the receiving devices then will populate a list of those devices that are out there, so they can start actually giving the operator a view of what sources are available. So as opposed to getting stuck into things like IP addresses and all that side of it, it's based purely on human naming. When as an operator you select an individual name as a source on the network, then and only then do we open up a unicast port on the network, and that allows that transmission of video and audio for that source between those two devices. And as you scale up, basically you open up more streams, because by default NDI does use unicast, and so each camera could do up to 5 simultaneous destinations before you run out of bandwidth. And other elements you'd have to watch out for are things like CPU load and network load. But again, it's quite easy to sketch out if you sort of follow this model of design to actually say, okay, well, how many destinations does that device need to reach? And then you can design your network to be an appropriate level to accommodate for that. And I think, Dean, one of the things that I get alongside with all of this is that, Panasonic cameras only support NDI HX, but I believe you've got some news for us on that today as well.
Yeah, we do. We actually have a very exciting announcement last week, and we do, we're a big adopter of NDI HX workflows, as said. As Panasonic, I think we have one of the most amount of products that support NDI HX, but we actually have a brand new PTZ that was announced last week called the UE100, and this is the first high bandwidth and also low bandwidth NDI supporting PTZ, that is also SRT certified, and we're going to talk a little bit about SRT, but it's also just to say that we put this in camcorders as well, which is really, really helpful. So with the NDI inside the UE100, in fact, we now have many, many new possibilities inside production and different ways, even interfacing, into like the TT1 system. I'm really excited to see what's going to happen in broadcasting. And just to give you a quick overview of what it looks like in terms of the specs, it's a small form factor, it's got a new direct drive system, it's a wider angle camera, and again, it's supporting a lot of different interfaces, and it's 4K 60p at once. So also PoE++, we still believe in that single cable message too, so we can do a lot of different things. So personally, like I said, Liam, I'm quite excited of the stuff that we're going to do in some more of the specialist areas as well, I think, with this camera.
Yeah, exactly, 100%. Now, especially you guys are carrying SRT on that as well. For those of you that don't know, our TriCaster Mini product is now the first TriCaster that can support SRT as well. So particularly where we're doing remote production workflows in the current situation that we're all facing, technologies like SRT can really go hand in hand with NDI and remote technologies like Skype TX that we're using today to open up a whole range of different workflow opportunities within that to solve different use cases for all of our customers as we go along there. Just to give a quick reminder of everybody with the new TriCaster Mini 4K, this is actually our first TriCaster which is only NDI. It has 4 direct NDI connections on the box, which will provide power over Ethernet and also DHCP. So With this type of device, there's no need for a network switch. You can connect your NDI cameras and they'll self-assign an IP address. We'll automatically be able to control them, but we'll also provide power as well. We can consume up to 8 NDI sources on there. We can use 2 Skype TX channels like we're doing today with Dean and our guest later on. And also then now the addition of that SRT NGIS really makes it an ultra compact, very, very portable system that can actually offer all of these features for remote production and more.
I also forgot to say that it's really the new stuff that we're doing, and as part of the VisRT group, we've been doing a lot of work. That NDI in VR and AR engines is really impressive, and the UB100 will also support the 3D protocol. So actually, we've got that package of the 3D NDI, and then putting it into graphic systems, like the Viz engine is really exciting. Really,
and we're actually
exciting.
you guys are doing an event with VisRT next week on VisR TV about that particular project that we worked on, which was utilising exactly those and bringing all of our technologies together there as well.
Oh, we will, and it'll be very for those that wants to see that how augmented reality is working with PTZs. But with the PTZs as well, I just talked about a lot of NDIHX supporting products that they support 4K, but we support NDIHX and HD. But you guys have an exciting announcement.
Yeah, we do.
The last couple of weeks.
Exactly, yeah. We've got a new camera of our own to announce, which is our NewTek NDI PTZ UHD. This is a first of its kind at the moment, and is actually the camera that I'm using for my studio camera today to present to you guys. It's a 4K NDI HX camera, so as opposed to yours, which is a full NDI device, this is using the lower bandwidth NDI HX, but is running at around 27 megabit per second for a 4K stream. We offer a 30x zoom, and again, we've got proper dedicated servos on there for really smooth movement and action, along with a 30x optical zoom. So that's going to coincide alongside our existing PTZ1 camera. And again, like all these technologies, you know, we can bring all of these different cameras together because our production systems do support the protocols that all these cameras can understand. So you can mix and match the camera and the technology depending on what you want to use on your network, depending to me on budget price points or deployment types. All of those can be used and consumed because all of these products all speak NDI together as well.
Yeah, and speaking of that as well, this is a big question for people. I need expensive high-end network hardware for video over IP, but there's a lot of existing products that have come right down in price, right? Especially in switches.
Yeah, and this is part of the reason that we set out to use gigabit, because it's one of those technologies that's matured. The price point's incredibly affordable. It enables that ability to use commercial off-the-shelf hardware rather than having to use high-end switching gear to support the likes of multicast. And so, you know, you can almost use any network switch that you like. We do recommend an enterprise class network switch because depending on the scale of the deployment you want to work to, you might want to be fine-tuning that network hardware to give the best performance, because we do require higher availability. We are talking full frame rate, real-time data moving across these networks. So it really is an question all about scale. I mean, here today I've got a handful of sources, so I'm just using a simple 8-port switch that didn't cost me that much, but it's more than enough to do a small scale production. But as you start hitting these larger deployments, especially these ones where we start looking at hundreds of sources out there, then you're going to need something of a sort of higher grade that you can actually tune and adapt to NDI as you see fit. And that's something that both me and Dean can help people with if they've got any questions on that front as well. And I think it's one of those things also in that it comes up is about this notion that video over IP has to be broadcast resolutions and frame rates. I guess you get that a lot as well, Dean.
Yeah, we do, but again, like you said, NDI is quite scalable, and depending if you want to do HD, lower bandwidth, higher bandwidth, depending on your production, it's actually just become more accessible because NewTek, even we're excited to see that, you've released some more tools for iOS devices, right? And this is quite a new announcement, especially over Wi-Fi and being able to convert different sources into NDI and also be able to control them and use them. So this is great for, again, taking existing hardware, and then we can also combine that into our workflows and ecosystems that say if you're a NewTek operator and also in a Panasonic operation, it all starts to blend together using these types of software. But you also did this with iPhones, didn't you? This is a little bit more eSport style.
So the basically the idea of the iOS camera is it's an NDI HX based camera, but given iPhone and iPads now support up to 4K resolution, we can actually bring those in as sources now as well and utilize those fantastic sensors those devices have, which opens up all sorts of different deployments again. But as alongside the camera, yes, we do have a effective NDI HX capture as well, because this was a high demand from the AV industry, was the ability to actually capture content off screens. We can already do that using our scan converter, to capture PowerPoint and desktop feeds, and now we can do the same with those mobile devices as well. And I think it's worth pointing out that both the NDI camera and the NDI capture apps are completely free of charge until the 1st of June on the Apple App Store for anybody that wants to start utilizing those today. And again, you can start using those with those free NDI tools to start getting up and running and experiment with some different workflows there as well. And I think it's worth mentioning, going back a little bit to the multicast angle here, I think as well, that, you know, we touched on that with this higher end networking side of things. And actually there's a common misconception, I think you encounter it as well, which is that you need multicast for video over IP, and it has to be multicast, and that's really not the case with what we're doing.
No.
I think it does kind of come down to that point, I think, where when you're looking at these uncompressed protocols, that the only way to do multiple streams and encoding is by using that. And again, just to refer to that earlier slide, because we use compression and unicast by default, we can coexist. We can actually have all these multiple streams going out before we need to add that additional complexity of multicast. But I think for both of us, you know, we both support multicast on all of our cameras and all of our production systems as well.
Yeah, which makes it, you know, a lot more flexible when we're pinging to, again, multiple destinations, and what we need to adjust for different workflows for different events. So yeah, in terms of like the operability of this and scalability, it's very, very flexible.
Yeah, and I think also with that interoperability note on the multicast side, we do have 2110 gateways. So for those that do want to go an uncompressed route, and again, there's tons of applications where uncompressed is suitable as well, we can fully interoperate the whole NDI environment with those uncompressed protocols as well. And that's another benefit to us being software defined. One and a question I get quite a bit, Dean, is that NDI HX is unusable with audio mixers and external audio sources. Do you want to expand on a little bit on that for us?
Yes, and I'm excited to discuss this a little bit more with a special guest if we have a little bit of extra time. But yeah, there's software that's available to also either adjust it inside the CPU systems, which are also doing the switching. You know, like I said, they're hybrid switcher and computers. So in the TriCaster series, Liam, I know that we can do audio adjustments as well as in the HRC 100, so that if we do have a delay, then we can start to match it. Also, inside the cameras, we do have a 3.5mm audio input, so we can actually embed the audio and the video down the Cat5 signal or the LAN connection, and then we can adjust the volumes as needed and the settings to make sure they're synchronized. So it's not totally, again, don't be put off by the latency. So it's totally possible.
Yeah, it's all completely tunable, and it's this thing as well as NDI is only for computers, and we can't use it with our existing equipment. You know, there's a lot of people out there with HD SDI and HDMI devices that they want to utilize, and I think it's a common misconception that they can't be utilized in an NDI environment. But you guys again have been doing quite a bit of work with that with your existing product lines as well, haven't you?
Yeah, we're doing that a lot, and again, some cameras might not support NDI HX or NDI, but you can use existing encoders and decoders. We use new tech encoders quite heavily in what we do. Again, just taking the output of the camera, of the HDMI, for example, and then we can put it into NDI video signal that can be ingested into a system. And it's also a myth that you can't use Panasonic controllers as well as TriCaster systems as well. It might overload. You can use up to 5 devices to be controlling the camera at one time on a single network. So it is absolutely possible to do that.
Yeah, and on that front, another new thing that NewTek have announced recently is we've brought out the new Spark Plus I/O devices. So these are based on that FPGA hardware implementation of NDI. It's our 3rd generation of the Spark Plus range. And with these particular models, we have the ability to use HDMI or 3G SDI. And not only can we encode into NDI, but we can also now decode as well. So these are real multi-purpose units. They have an inbuilt camera mount, so you can quite easily attach them to the hot shoe of an existing camera or put them onto, say, a Magic Arm as part of your camera setup as well. But they also open up a whole ton of different deployment opportunities for gameplay capture, esports use, anywhere that you want to be able to go in or out of NDI, a single source at an individual time there as well. And I think that takes us quite neatly onto our guest today as well, because a couple of the last questions we get a lot is that NDI is compressed, so it's not fit for broadcast.
Yeah, and also NDI HX is compressed for use, way too compressed for use, but we've been working together on an incredible project, and the Supreme Court of the UK have been using an NDI HX system. There's some pictures here, but it's equipped with a number of HM130 Panasonic PTZ cameras, and also I believe in the TriCaster TC1 was being used from your side as well, and completely changed. Adjusting from an analog traditional workflow to an NDI system was quite a huge project. So very excited for this guest.
Yeah, and so without further ado, we'd just like to welcome Dan Money to the show from the UK Supreme Court. Thanks for joining us today, Dan.
Hello, Dan. How you doing? There
So
we go, technicals.
Yeah, no, so we got there. So, Dan, just a quick one. Just got a few questions for you today. So, first up, would you give us a quick, short overview of your setup and the technology that you're currently using at the UK Supreme Court?
Yeah, sure. So, we purchased. We've got 3 PC1 TriCasters that we're using essentially as our core system. We're using Panasonic 130 HM130 cameras, 4 in each courtroom. They're obviously PTZ remote controllable cameras. We've also thrown into the mix the Panasonic 150 RP150 camera controllers, which is really as was touched on earlier. You can do all of the control from the TriCaster control surfaces. But the Panasonic 150s just allow you to go into that little bit more granular control, from iris control, white and black balancing, and seeing the results of what our engineers have managed to get out of using both those cameras, those controllers, and obviously having the TriCaster as the central control platform has been quite revolutionary for us, really. It's allowing us to have cameras in different areas, have screens in different areas. We've taken what was quite a rigid broadcasting platform and created a real flexible sort of dynamic system that we're now finding a lot more uses for them than just solely recording the record of our case and broadcasting it to our court users.
And where did the idea for NDI come about, and specifically why implement an NDI HX workflow in particular with your current infrastructure that you have in the UK Supreme Court?
Well, our equipment was reaching end of life. A lot of it's near 10 years old. It should have been replaced a long time before we actually we got round to doing it. So it was kind of one of those situations where we knew we had to upgrade everything, and kind of used it as an opportunity to start with a blank canvas. And my background is more on the IT side, networking, and so the idea of being able to combine video with my pre-existing skills was obviously very welcome to me. And just the fact that we've got, as most sort of modern companies would do, we've got a really good IT network in place already. So the ability to utilise that rather than having to recable for SDI and for sort of some of the more proprietary setups, to me just seemed a modern way of working. And whenever I look at a new system and try to develop something, I always think about, yes, we need to do what the old one was doing, but actually, what can we do with this one going forward? So to have a network-based system, to me, it just seems to open up so many possibilities going forward. So that's the main driving point behind it, making something that's going to be future-proof, essentially.
And talking of sort of using new platforms and stuff, you guys have been using Microsoft Azure quite heavily as well for your live streaming. Have you been able to implement that and live stream to additional outlets, so things like news agencies, for example?
Well, it's an interesting one because it was really working with Microsoft originally, looking at their Azure Media Services platform, that got me in touch with NewTek, because one of the recommended, Microsoft have about 10 recommended items, i.e. encoders, that they recommend to work with the Azure Media Services platform, and the NewTek TC1 TriCaster was one of those. So that's kind of what created the relationship between myself, Microsoft, and NewTek. The Azure Media Services, again, it's just a basic encode. It's an RTMPS system, so you can send an image from any encoder to it. But it's the more sort of, it's incorporating AI technology and a lot of exciting things that are coming down the pipe as to what you can then do with that stream once it's running. So you can have transcription services on it, it's facial recognition, all sorts of the cool things being talked about at the moment, which I think, you know, really going to come into their own over the next few years. So that was kind of what got me into looking at the two different products and how they work together. And, you know, out of the box, you can stream directly to Azure Media Services from the TriCaster devices that we've purchased. But we've actually gone beyond that now, because one of the things I found out from Microsoft is to get some of the additional functionality, you essentially have to set it up as a custom profile. But that's actually been quite exciting, because that's allowing us to now get into some of the more sort of futuristic elements of the stream, should we say. It just works seamlessly. It's kind of effortless. You know, we've just put a case live today, and we're doing it all remotely, and it works.
Fantastic. And so you managed to reach quite a lot of different sort of news outlets that actually started picking up content from you guys as well, didn't they? I mean, they were taking both the live stream and an NDI decode on the back of the building.
That's right. I mean, we you know, some of our cases draw a lot of attention because they're dealing with points of law that affect, you know, the United Kingdom. So we've always had the requirement to be able to offer news broadcasters and sort of any media outlets the ability to ingest what we record in-house in the court building, essentially. So we've got a feed that's managed by Sky that goes directly to a building that we call Millbank, which is just over the other side of where we're based in Parliament Square. We obviously send our own dedicated stream out to our websites using the Azure Media Services platform, but then we also have direct connection points around our buildings. So essentially we can have TV vans pull up outside and can connect directly into our signal, which is now being made available in HD to anyone who wants it. And if it's a really large case, they essentially will line up around the building, and they can sort of daisy chain all of their vans together. And then obviously use their own sort of broadcasting platforms to get that signal out to wherever they need it. So it's we've got quite a lot of flexibility there. There's not been something that we've been asked to provide that we've not been able to yet. So that's pretty cool.
That ties quite nicely into this question, which I personally remember this very well, and it was how were the Supreme Court able to scale up when court cases with greater levels of public interest were taking place? And I specifically remember after we did the project in the summer, receiving a BBC News notification, and it was actually for the Miller versus Prime Minister case, and that was one of the biggest, highest profile court cases I think ever in the Supreme Court, and that's when the system really went live, didn't it?
Yeah, that's right, Dean. I mean, it wasn't by choice, and it certainly wasn't the way that we had planned it, but because obviously the prorogation case, Miller versus Prime Minister, kind of come out of the blue to us. My deployment timeline was essentially brought forward by about 2 months. So in the period when we should have been testing it, we was actually going live with it. So you're absolutely right, Dean. I mean, obviously, I was quite nervous myself. We'd done a lot of obviously internal testing, and had obviously, you know, created, you know, we'd tried to sort of create a mock environment of how that case was going to run. But of course, it was essentially installed over the summer, and that was the first live case that had ever used this new system. And to have that level of scrutiny and that level of media coverage, and to essentially be going live for the first time on a in production environment untested system, it was not ideal, and but it worked. And I guess in a way that's credit to the faith that I had in the system, because I had to do a lot of reassuring, shall we say, to senior management and the stakeholders who were involved with that case. But it didn't let us down, and that was, you know, it was impressive. It was an indication to show how quickly you can implement something if you're really forced to, which I guess is a similar situation we're in with the current situation, isn't it? So.
And that actually leads me quite nicely into the next question, actually, there, Dan, which is, you know, during sort of the lockdown situation, how's the Supreme Court been using NDI? And I understand also you guys have just started using things like our scan converter tools with Cisco WebEx to link everything together as well.
Absolutely. Well, I mean, it's really NDI, the TriCasters out, the AMS stream setup. It's really come into its own, you know, due to the COVID-19 situation, the fact that we're all home working now. It's kind of vindicated my decision to go down that route, which is pleasing for me, because again, I had to do a lot of persuasion with management board that we was taking the right decision when we decided to go with this setup. So the scan converter is a great tool. It's one I hadn't had to use before, but I had heard of it. What the scan converter does essentially is take any computer device, what you're seeing on the screen, as presented as an input to the TriCast or to whatever new tech device that you're using. So that input we're essentially taking from a PC we've got back in the office, which is running the WebEx conferencing platform. We've always used WebEx for various sort of secure conferencing, and to be able to just output that computer source directly as a video input and then essentially encode it as a stream to our website felt at the time like quite a crude way of achieving what we needed, but it's been so reliable that we've run with it, and the video quality is very, very good. I mean, we're only presenting the output of WebEx anyway, so it's, you know, it's not got to be, it's not a 4K HDR production or anything, but in terms of presenting very clear audio, very clear video, and essentially allowing us to carry on to maintain visibility to justice, which is what the Supreme Court is all about. We wouldn't be able to do that without the setup that we've currently got.
Fantastic. It's quite amazing, again, in times of crisis, how much technology gets, you know, forced into the next phases of production, like you said. But the current situation, like, how informed, what are you going to do next at the Supreme Court? Like, because again, talking about having to adopt technologies and having to deploy things very quickly, what's kind of like your vision of what's going to come next, I guess, and what you personally feel, I guess, is going to happen to installations such as yours globally?
Well, for me personally, before COVID-19 and the situation that we're all experiencing together came about, it would have been moving on to things like green screen for justice interviews, and, you know, a lot of the really cool stuff, maybe the more sort of transcriptional service around media services, as I touched on earlier. But what's actually, I think, going to be the reality of what we'll be looking at is how do we end up in a situation where some elements of our judiciary are working virtually and some are back into the building, because I think with social distancing, it's going to be a while before we can return to business as usual. So I've just been in a meeting today where we've been discussing exactly that. So looking with our broadcast team about how we start to bring in potentially virtual video sources, but mix those with a combination of our live cameras back in the courtroom. And then again, if you've got different quality, different compression rates coming in, how we get it to look natural on the stream when we present that to the public. So I think some of the things that we'll be looking at have kind of been forced on us by this situation, but actually I think one thing that it's taught a lot of the technical teams that I work with is actually the way that we're working now is quite an efficient way of working, so why not let's look to build upon it. So even in times when we can access everything that we used to be able to, maybe we don't need to be, maybe we can have an opportunity where some justices are working remotely and some are actually in the courtroom.
Fantastic.
I think we can all agree. So you go ahead. There's a little lag, isn't there? But I was just going to say, like, even what we're doing now, and Liam as well, for you doing this remote production from home, and even for us as Panasonic, I can say us as a corporation has been affected massively in that sense. I totally agree with you, Dan. I think, like, the way that we're working is forever changed doing this remotely and more efficiently.
And Dan, I mean, do you think that any of this would have been possible if you guys hadn't been embracing IP or software-defined production in the first place?
No, not in the way that it's been done. And I mean, the broadcast team that I work with, you've got a great mix of people there. Some who are used to using this type of technology, and some who, you know, it's absolutely alien to them. They're very much into analog and separate devices for every unit that you need to do a specific job. And so I had a lot of pushback when I presented this, and I kind of had to almost sort of push it through on my own merit, sort of kind of taking responsibility on my shoulders. So it's been quite, even some of the engineers have turned around and said, you know, we wouldn't be in the situation we are now, able to continue if the decisions that we made in the summer hadn't have been made. So it's been quite nice to have sort of my decision making vindicated, but albeit I'd much prefer in a different circumstance, of course. But the fact that we've been able to, I mean, I had a great comment from one of the justices the other day, which they said, despite the circumstances, we've not actually had to adjourn or remove a case from the list. We've continued exactly as we would do if we could still access the building. I'm not saying cases haven't fallen out of the list, but that's by the choice of the parties, but not because we've not been able to produce based on the technology that we've got.
Fantastic. And we've had some, just a quick one, guys. We've got a little bit more time, but we just had some questions actually come back from some of our audience out there today. One thing you might be able to answer for us, actually, Dan, because I don't know the answer to it myself, this one, is it possible to use Connect for Azure and IR streams as input? Is that something you're familiar with? Or?
No.
it's one we'll come back to on people. That'll be absolutely fine. We'll come back to it. So the other ones are kind of
to anybody. So
yeah, just I thought I'd throw it out there, see what happens. So a quick one, Dean. You might be able to answer this one. Is do NewTek and Panasonic mixers have built-in delays to allow matching of NDI and SDI connection if needed? And will the UN UE70s be upgradable to 4K by upgrade?
Oh, fantastic. Right, so first part, the switches, yes, we do have the audio delay function as well. In fact, Dan, how, just quickly, do you do mixed audio with the NDI signals as well? Because you've got the cameras mounted, right, and it's all going, but how are the microphones synchronized for lip sync?
The microphones essentially are still on an analog network. We're looking to go that in the future to network those as well, using sort of the Dante protocols, which is completely usable within the TriCasters. And but in terms of bringing that mix into the TriCaster, we're essentially just taking an output from the audio mixer, which does some basic level mixing for us, and just taking a direct output into the TriCasters themselves. We have got a delay unit in the mix, but to how much the engineers are having to use that, I'm not entirely sure, but there is one in the signal flow, should they need to. But
Yeah.
you can do that, Liam, can you do that within the TriCasters, the delay?
Yeah, you can. So both video and audio delay are individually tunable on every input. So all your audio inputs, all of your video inputs, they're all offsettable. So it's all done in milliseconds. So you can be incredibly precise with the timing if that's what you want to achieve there as well. And talking of timing, sorry, Dean.
Oh, I was going to say the last one. I was going to look like a politician dodging the question then. So for the UN70, the upgrade to 4K, the UN70 does only support NDI-HX at this time on the first one, so not for 4K. But as I discussed, the UE100 will be the 4K option for supporting those NDI 4K workflows.
Yeah, complete. Awesome. And another one was somebody asks, a delay of 5 frames is mentioned for HX. Is that totally fixed, or is that just the codec delay, or does that include receive buffering? Because I'm trying to get a feel if the delay would be the same each time. From experience, pretty much the delay is consistent. I don't really see much variance from any projects I've done or things I've worked on. Dean, Dan, have you guys had any experience with getting slightly different delays from different cameras? Because I tend to find it all in sync myself.
Not personally, I've not witnessed any, and I've not had any of our broadcast engineers obviously bring that as an issue to me. So they seem to be fairly happy with how it's functioning.
Yeah, so as we know, broadcast engineers are the most vocal as well.
Exactly.
Projects that we work with.
Yeah, fantastic. I mean, there is, just for other people just so they're aware, I mean, certainly on like the live production systems and that, there is timing involved as well. But then, where there are devices that can't necessarily strictly be timed, that's why we give you those adjustment rates within there. But the actual delay should be consistent depending on the type of NDI and device you're using. Of course, we can't actually control what's upstream or downstream of an NDI device. So do be aware that technologies like HDMI are slightly higher latency than, say, SDI, for example. And it's still the same in traditional broadcast. So we mentioned earlier that it's always going to be what combination of devices and what the chain looks like outside of that. So those latency numbers are very much referring to once you hit an encoder and we're within the network, then that's where we can be pretty consistent with the numbers on there as well. Dan, this might be a good one for you actually as well, which is what about security and privacy issues regarding accessing NDI sources and being able to control them? So if you're the same network as a camera and getting access to control settings or moving cameras through a web browser or studio monitor.
Well, it's a good question. I mean, we're in a fortunate position where our broadcast network has always been separate from our LAN that the users use. I mean, there are elements that overlap, such as some of our storage devices can see both networks for obvious reasons. But in terms of the security aspect, we've kept the networks very segregated for that reason. It doesn't mean you can't use, obviously, existing cabling in the building, but essentially they're running on 2 different subnets. But we're quite fortunate in the sense of most of the work that we do is all in the public domain, hence why we broadcast it to the websites in the first place. So in terms of actually needing to secure the video, it's not such a big requirement for us because we want the public to view it. So, but you're absolutely right in terms of someone, because our building is open to the public. So in terms of someone coming in and being able to take over a camera source or something like that, that would obviously, would not be desirable.
There are ways of grouping these things, because I mean the actual automatic behaviour is only on a single subnet, so you'd have to be on that subnet, and by that I mean the last 3 digits of any IP address. So you can lock things down with physical IP addresses. You can do things in your network architecture like discrete networks or even separate VLANs that other ports and networks can't reach to. But we also do include within those NDI tools we mentioned earlier on something called Access Manager, which allows you to create groups of NDI sources. And unless you know what the name of the group is to send or receive, you're not going to be able to do this automatic detection. So there's been quite a lot of work in actually ring fencing what NDI does, but still enabling all those great automated side of things as well. And if you get really concerned, I said there's discrete networks, and you can also actually start doing more things at the network level and locking down, which is where those enterprise class switches really start coming back into their own there as well. We've got one other question which has come up over from YouTube with our friends over at CVP as well, which is, do you know of a way to output your OBS feed as a webcam feed? Because I know there's a virtual cam for Windows, but is there a way to do it on Mac? Well, yes, now there is. That virtual camera tool is now called Scan Converter for PC, again, for one of those free NDI tools. And that now is also available for OS X as well. There are some limitations with the OS X implementation, but we are progressing on that as well. So, yeah, you can certainly do that with Apple Mac applications now as well. One last one, Dean, I think you can answer this one as well, which is how many NDI streams are available from one camera at the same time, and is it true that only one of those streams can be high resolution or full resolution?
Oh, that's interesting. We have multiple streams out of the camera. So we have our NDI-HX, our main proprietary stream, which is going to be the best quality. So we have priority modes inside the PTZ. So the HN130, Dan, you have an NDI-HX mode. However, it does also output a motion JPEG stream at the same time. So what that is for monitoring. So if you wanted to go into a web interface of the camera, you can then use that stream as well. So yes, typically we do say it is the one NDI-HX stream in which you can customize outside the camera as well, but then you can take it into your system, and as you say, you can distribute how you want to do that NDI-HX stream how you like. And I don't know if you found, Dan, for HM130 and NDI-HX, it works fine with that one stream as well.
Yeah, I mean, we've certainly had no problem. We've looked at doing sort of things for resilience and backups, as maybe having different sources coming out to different servers and things. But yeah, I mean, for what we do, we're just using that one proprietary stream that's coming out as NDI-HX.
Yeah, and you can use those streams multiple times. I mean, certainly with our cameras, I've done up to 5 streams simultaneously in some cases. Because of that unicast protocol, we can repeat that unicast stream multiple times. But at some point, you're going to run into network bandwidth issues, depending on how many simultaneous streams you're pulling, or encoder issues. Now, if you get to that point, and it's quite difficult to get to that point with unicast, but then you can flip over to multicast, and then you can actually get even greater scale again. So it's going to depend on the device and the technology that's being used there, but again, just that simple model of just drawing a circle and mapping out how many streams you're going to do before you get worried about cabling is kind of critical to actually start build up what type of network topology you're going to need. Are you going to need multicast or unicast? But I think the majority of people, you find unicast will meet most of those needs hands down every time.
Just to say as well, I mean, we've done events at Redshark, Liam, where I was using the NDI-HX streams from the Panasonic PTZs, but I was using Studio Monitor at the same time. I was using it, ingesting it to HC100. It was going into a TriCaster TC1, and that was off of the one NDI-HX stream as well. Anyway, so it was, already doing a point-to-point for live, and it worked absolutely fine for us anyway. So yeah, it's no limitation, I found.
But one of the tests that I've done just to check before we've purchased everything is for due diligence purposes was literally to create the longest run that you could possibly do from camera to control source, traversing different switches, different cabinets, different networks, and I couldn't make it break essentially, and even I tried my hardest, but So yeah, I mean, to me, it's a really resilient platform, and that test to me kind of sold it to me. I was thinking, because we've got some really old cabling in parts of the building, but then we've got some really modern cabling in others. And I know Liam, but sort of we done work around using converters going from fibre to which at the time wasn't even supported, but I proved the fact that it could work. So that we wasn't even using particularly expensive equipment when we was testing at that point. So yeah, it's flexible.
Fantastic.
Excellent.
We've got a couple of last quick questions, which I'll just answer quick. One of them, is there a plan for an NDI camera app? We don't really talk about any future developments we've got going on at the moment in UTEC, but we do have currently have the iOS implementation for those, so that's what we currently have released to the market. But I'll certainly pass that back up to our developers and ask them about what's happening next. The last question is, how many streams can we get on a gigabit network for 1080p, for example? Rough rule of thumb, it's just based on those bandwidth numbers of around 150 megabits. So you should be able to get around 7 streams quite comfortably of 1080p 50 in each direction on a gigabit if you're using high bandwidth NDI, maybe about 8 times that if you're using NDI HX on a single link. And of course, if you're using 4K, it's going to be a factor of 2 in, 2 out per gigabit. But you can really roughly divide the numbers, just allow a little bit of overhead at the top there, just for scaling that down. But again, Dan, you've had no issue sort of using I think you're predominantly using gigabit Ethernet throughout, aren't you, at the Supreme Court?
We are, yeah. No, we've not had any bandwidth has not been an issue at all.
Fantastic. Well, Dan, Dean, thank you so much for your time this afternoon. To all of our audience out there, thank you for joining us as well live online. This will be cached and repeated, so it'll be accessible for viewing later on. But Dan and Dean, thank you very much for your time, guys, and I hope you all keep safe and well.
Thanks so much, Liam. Thank you, Dan.
Thanks, everybody.
All the best. Thank you,
Thanks a lot.
everybody. Cheers.
Take care.
Take care,
Bye-bye.
everyone.